In this lesson, we're going to talk about theoretical and percent yield. When we do a calculation to figure out how much product we can make, that is what is known as a theoretical yield. It's the maximum amount of product possible. For example, if we had 2 slices of bread and a slice of something, we can make 1 sandwich. The maximum amount we can make is 1 sandwich. If we had 4 pieces of bread and 2 pieces of deli meat, we could make 2 sandwiches. In these 2 examples, we both had stoichiometric amounts, but we can also do this when we have to deal with a limiting reagent question. For example, if we have 7 pieces of bread and 4 pieces of deli meat, then we could still only make 3 sandwiches because we run out of bread first. But that's still our theoretical yield. Doesn't matter whether we're starting with stoichiometric amounts or non-stoichiometric amounts of reactants. The theoretical yield is the maximum amount we can make, and that is the calculated value. However, in reality, we can't always produce as much as we theoretically could. If we're making sandwiches, a piece of bread might fall on the floor, someone sneaks a piece of turkey, the dog steals something off the counter. All of these things can happen. And so we don't get to that maximum amount. In a reaction, we see something very similar. Sometimes reactions just don't run to 100% completion. Sometimes we lose things without realizing it. So say a gas leaks out of our container, or we just have unrecovered product. If we're filtering something, sometimes some of the product will get stuck to the filter paper or even to the glass beaker it's in, and we just can't get it all out. So we can't get the maximum amount out of that reaction. The actual yield is the amount of product that's actually obtained after we do the experiment. So we also call this the experimental yield. And this is going to be less than the theoretical yield because we can't make more than we theoretically could. I can't suddenly make 8 sandwiches when I only have 7 pieces of bread. I max out at my 3 sandwiches. So actual yield is a measured amount. We determine that experimentally. What we do with those values then is calculate the percent yield. And whenever we do this for an experiment, we want to try to get a value that's as close to 100% as possible, because that means we had a very efficient reaction. But can it ever be greater than 100%? No, because remember, the actual yield has to be less than the theoretical yield. So our percent yield is always going to be less than 100. If you should ever do an experiment and it ends up over 100%, either you had a math error in your calculation of the theoretical yield, or you had an experimental error and you're weighing more than you think you're weighing. So maybe the sample is still wet, you're also weighing some water, as well as the product you're trying to find. Just like with other percentages, we'd find the percent of something by taking a part over a whole times 100. In this case, we have the percent yield equals the actual yield, that's our part because it's going to be less than the theoretical, over the theoretical times 100. Remember, the actual yield is our experimental value, what we actually measure when we do the experiment, and the theoretical yield is the calculated value. Let's look at an example. What is the percent yield if the theoretical yield for a particular set of conditions is 0.750 grams and the actual yield is 0.606 grams of zinc sulfide? We're given a balanced equation here, but because we're given the theoretical yield and the actual yield, we're not actually going to need to use that equation. We don't have to solve any stoichiometry problems first. So the percent yield equals the actual over the theoretical times 100. We can plug in our value for our actual yield, which was given in the problem. That would be the measured amount. And we put it over the theoretical yield, or the calculated value. In this case, we were given the calculated value, but we multiply that by 100, and we get our percent yield of 80.8%. So in this case, we were given the theoretical yield. Many times you'll have to calculate the theoretical yield, and that's just doing the same type of stoichiometry problems that we've been doing. Let's look at another way we can use that percent yield formula. If we start with 42 grams of potassium chlorate, what is our theoretical yield of potassium chloride in grams? And then the next question is, if the reaction runs at 87.3% yield, what was the actual yield of the reaction? In this case, we're not given the theoretical yield. We actually have to calculate that first, and then we'll use that percent yield formula. Because I know I need to do a stoichiometry problem, the first thing I'm going to do is get my molar masses for all my substances so I have them ready to use when I need them. We're trying to find the theoretical yield of KCl, and we know how much we start with the KClO3. So I'm going to start with the 42 grams of KClO3. I'm going to use the molar mass of that to convert to moles. Then I'm going to use my mole to mole ratio for my balanced chemical equation, 2 moles of KClO3 to 2 moles of KCl. Next, I'm going to use the molar mass of KCl. I'm going to go back and check my units. So grams of KClO3 cancel, moles of KClO3, moles of KCl cancel, and I'm left with grams of KCl, and I get 25.5 grams of KCl. That is my theoretical yield, my experimental value. And that answers the first question. Now I need to look at the second question. We know the percent yield. We're trying to find the actual yield. We know our formula, percent yield equals actual over theoretical times 100. I'm going to plug in the values I know. I have 87.3% equals my actual, that's what I don't know, over my theoretical times 100. I divide both sides by 100 and get 0.873 equals actual over 25.5. Then I multiply both sides by 25.5, and I get my actual yield to be 22.3 grams. And this is a reasonable answer because I expect my actual yield to be less than my theoretical yield. And in a lab, a lot of work goes into trying to improve that percent yield. Because in a lab where you're making something for one experiment, it's not that big of a deal if your percent yield is 70% versus 90%. But if you're making large quantities of something on an industrial scale, then having a percent yield of 70% versus 90% is going to be a huge difference, not only because you're not producing as much product, but also because you're going to have more waste left over to have to deal with.